Hey, welcome back. We're just about to take a look at day 5 on Advent of Code, and I'm so glad you decided to join me for this one because I really think this may be my favorite challenge so far here for two reasons, really. Number one, the way it's presented is, again, there's something a little bit sneaky about it. We'll explore what that is in just a sec. And then the other thing is basically after we've processed all this data, there's an interesting algorithmic part that we're going to do afterwards. So we're going to return to our discussion about efficiency, time complexity, space complexity, more algorithmic kind of stuff, which we haven't really been discussing too much in some of the more recent videos. So what is this one actually asking us about? Well, basically, we're talking about plane tickets, right? So we're trying to board this plane, and if we look at our puzzle input, it's all stuff like this: F's and B's, L's and R's. It's basically these codes that represent which seat the passenger is seated in. So our task is to look at these codes and kind of decode them to give us information about the row and column that the passenger is seated in. And then from there, we're going to find this seat ID according to some formula that they mention in the description. We'll talk about the exact way we're going to get that soon. But before we do, I just want to talk about something related to our general strategy here. So we've talked about this before, that in these problems, we generally want to make it work, make it efficient, and then make it beautiful, kind of in that order. We've been talking about making a few changes to this. So originally I said develop the most naive solution as part of step 1. I'm sort of switching that over to develop a naive solution. It doesn't have to be the most brute forcey thing. In fact, for this particular example, I think if you've heard the expression, work smarter, not harder, I think that really applies here. So what I often like to say, which is kind of related to that, is some of the most important parts of programming happen before you write your first line of code. So whether it means just pencil and paper, trying to get a better understanding of the problem, drawing diagrams and stuff like that, whatever it is, I think by conceptualizing the problem in a good way the first time around, it can really help us out a lot when it does come time to write the code. So basically, we're just going to take a detour for this one before we actually get into the code here, which I've got set up whenever we're ready. Basically, we're going to take a look at how we can better understand the problem, and that might inform how we decide to solve it. So if we look at the examples, basically they run through an example of this one. Now, the first part of this, which is the first 7 characters, this refers to which row the passenger is in. So that's quite a few characters. The second part of it, which is only 3 characters, corresponds to the column. So since that's a little smaller, that's the part I want to focus on. Okay, so let's go over to our whiteboard. What I want to do is basically take a look at this specific example because we sort of already have it worked out in the description. And then I want to talk about how we can use that to sort of classify all these possible values. And this is why I chose the column part, because I didn't want to have to list out all 128 possibilities for the row part of it. Okay, so let's start by actually running through this example. So what this actually means is basically that the passenger is seated in the right half of all of the columns. Okay, so if we were to take all of the columns here, we don't know how many there are yet, but we'll just say we'll divide this in half. And now we know that they're seated on the right half of it and not the left half. And then the next character refers to which half of that half they're in, right? So if they're in the right half, basically it's the left half of that. So we're going to divide this up further. And just to make sure this works for all of our examples, I'll just divide up the other half while we're here. And then basically this last one is going to have us dividing up the resulting half, again, into halves of their own. So I'm just going to go ahead and do that just to make sure this is all nicely well prepared. And we're sort of seeing a half of a half of a half. That would be an eighth, right? So we're basically dividing this thing up into eighths. So there are 8 possibilities. So I'm going to label all these, and I'm going to try to follow the convention that they did in the description, which is to make these 0-based. Unlike some of the previous challenges where we had some 1-based indices, these ones are the more expected 0-base. Okay, cool. So let's actually run through this example for now. So the first thing is this R, right? The right half. So we know it's going to be somewhere in here. More specifically, we know it's not going to be these ones. Actually, I guess that's equally specific, but it's just a different perspective on it. Okay. Then we can move on to this next part, which says L. We're going to be in the left half of the remaining part here. So we'll get rid of the 6 and 7 possibilities. And then we'll look at this one, which says R. We're in the right half of this remaining part. So we'll get rid of the 4 over here. And it looks like 5 should be our answer. Now let's just compare that to the input. And yeah, it looks like column 5 is actually what we're looking for here. Okay, so nice. Not bad. I mean, that allowed us to get our number. And I guess we could go ahead and actually fill that in down below. So I'll just get rid of all the clutter on the screen. And then RLR is equal to 5. Now we could try to classify the rest of these. We could say LLL. That means we're in the left half of the left half of the left half. So that one is going to be 0. If we look at the next one, we're in the left, and then we're on the left of that, and then we're on the right of that. Okay, so that one's going to be 1. Kind of wrote that 0 a bit big, but anyway. Left, right, left. Okay, so this is left, this is right, and then this is left. So we should get 2. And maybe you're noticing a pattern here. Anyone want to guess what this next one is? Let's try it. Left, right, right? It's 3. Okay, so we could continue with these, but I think you're maybe noticing it's basically counting up, right? This one's going to be a 4, this one's going to be a 6, and this one's going to be a 7. So basically this code uniquely and accurately represents just some integer number between 0 and 7 inclusively. Now, this might also remind you of something you've seen before. And in fact, this process that we went through is kind of reminiscent of a process you may have seen before. We haven't really talked about it on these videos yet, but basically it's sort of related to this idea of binary search, which is basically if you're searching in a sorted array, instead of just going through each element one at a time, you divide it up into halves. And that's kind of exactly what we've done here. So binary search. We talk about programmer instincts sometimes, so when you find that the problem is reminding you of something you've seen before, maybe follow that instinct, right? So binary search refers to binary numbers, right? In this case, this is basically the same as what we would get in binary, except instead of zeros, we're representing those using L's, and instead of ones, we're representing those using R's. So these really are just binary numbers that we're looking at. So it's a good thing we noticed that, right? Because that means instead of having to go through and write some sort of recursive function that, divides something into a half and then chooses the half of that and then chooses the half of that until it gets down to a single element, basically, we can now say, well, hey, this is just binary. So our task becomes a lot simpler, okay? I'm just gonna write some notes over on the IDE side. Basically, our game plan is gonna be this. So for each ticket, I think these represent tickets, or boarding pass. Yeah, that's better. For each boarding pass, what we're going to do is we'll say divide it into the row and call parts. We'll start with that. And then for each part, convert to decimal. Well, actually, sorry, convert to binary, so zeros and ones. And then we're going to convert the binary to decimal. By the way, when I say decimal, this could be confusing because a lot of folks, when they think of decimal, they think like, oh yeah, decimal, like 0.5, like that kind of stuff, right? Like 3.14. And, they might look at a number like this and be like, wait, that's not decimal. There's no like dot at the end of it and something after. So keep in mind, when we say decimal, I just mean base 10. Okay, so binary is base 2, decimal is base 10. So that's sort of the more standard number system we're used to working with, right? So when we talk about, for example, down here, how like the row is 70 and the column is 7, like these are decimal numbers, right? As opposed to binary numbers that look like this. We can kind of tell because, like, for example, those numbers have things that are not zeros and ones. Anyway, okay, so basically, I'm trying to think what would be a better thing to have on screen right now. I'll just leave this up for now, and yeah, we'll finish up this game plan. So we want to convert our binary to decimal, and then get the seat ID by combining these numbers. And we'll combine them in the way that they specify in the problem. I think it was like something like 8 times the row plus the column. It was some kind of formula, but we'll look at that a little bit later. Okay, so this is a binary challenge. We're really talking about binary numbers. That's fun. That's exciting. We've talked a little bit about bitwise operators, but not in the level of depth that I'd like to yet. So this is a good opportunity. So for each boarding pass, well, I guess that's a good first thing to talk about. How are we actually going to get this information? So if we look at the puzzle input, actually, so each of these is separated by a single new line. So on each line, we have a boarding pass. And sorry, the font I realize is a bit small there, but each one of them is basically something that looks like one of these. Okay, so I've got a little sample, and I think it's, just the example values over here. What we're going to do is, as we've done in previous videos, we're going to write out our code over here just to make sure that it works with the sample. And then once we find that it works with the sample, we're going to put it into here and try it out with the actual puzzle input using our fetch API code. There are other ways we could do that. Some viewers have suggested we actually download the file and then put it into our file system, use like an import or a require or something like that. And that's a great suggestion too. There's probably a way that we could do it directly from within the IDE by passing our authenticated credentials as part of the header, but I haven't figured that out yet. So we're just going to do it in this kind of piecemeal way. By solving it in here with just the sample and then bringing that code over here afterwards. Oh, and by the way, another viewer had a great suggestion to put this code on GitHub. So that's something I'm going to try to do after I finish this. So, okay. Do we have our game plan? Do we know what we're doing over here? Oh, yeah, another thing I guess we should mention is like we had this RLR stuff going on for the columns. For the rows, it's very similar, but it's B's and F's. I guess I'll leave it to you as an exercise to prove that this is also binary, to prove that it's going to work the same way as all this stuff. If you trust me, that's fine. We can move on from here. But yeah, basically the idea is that it's just dividing it up in the same way, front and back, but basically it's halves each time. So it's again like that binary search stuff. Okay, so I want to get this off the screen. I want to go full screen with our IDE so that we can actually dive in and start solving this code. So basically for each boarding pass. So right away when I see that, I'm just going to say const passes, and I'm going to make a new array to represent these things. So we've got our response text. We normally get that from like the fetch stuff over here. So basically I'm just using this sample, and then I'm just renaming it response text so that the stuff that follows will be able to just paste it in directly along with this code. Okay, so passes is going to be assigned the value of response text, also known as sample, dot split. Whoops. Dot split is not what we want to do. Yeah, dot split on the new line character. And of course, we want to do a dot trim before we do that, because otherwise we would end up getting something unexpected, because we have like extra new lines on the beginning and end of this string, right? So let's just console log passes for now to see what that's looking like. And nice, okay, so no errors. We've got an array with our 3 things in there, so great. We've got our boarding passes. Okay, so what do we want to do for each one? Yeah, so basically, actually, maybe that wasn't the appropriate spot for that. I'll just put that up here. And then basically for each boarding pass, I'm going to write a function that's going to run on a boarding pass. Okay, so let's call this process pass. And it takes in a boarding pass, and it's going to return some kind of a thing. So I'm just going to divide this up into the row part and the column part. So we'll say const row part is going to be pass.slice. Have we looked at slice yet? I'm not sure. If not, as we can see from this helpful description that's popped up over here, the way slice is going to work is basically it works on either an array or a string, and it's going to take the part of it that goes from this index to this index. It will include the element at this index, but it will not include the element at this index. So that's a good thing to know. We could now say call part is going to be pass.slice 7. Now I could say like 7 to the end, you know, like 7, I don't know how many characters there are, 11 or something like that, but this will just go to the end. So That's probably fine. We don't need to be any more specific than that. We could give it like a really big number, you know, like a million or something like that, but no, I think this is okay. So we've got our row part, we've got our column part. Now keep in mind, each of these things is just going to be a string for now. Oh, and by the way, we don't need to use slice to get these. We could use some sort of like regular expression, or we could do it more manually than that. It's really up to you. But basically the idea is we're going to get these two parts. We're going to convert them to binary. So actually, yeah, let's get our comments in here. So divide it into the row and col parts. Done. Okay, and then for each part, convert to binary. All right, I think we can handle that. Then we're going to convert our binary to decimal and get the seat ID. And ultimately, that is the thing that we want to return, is the seat ID. So once this stuff is all combined. So we'll just say return seat ID, even though we don't... Whoa, okay, yeah, so maybe that's a problem since we don't know what it is yet. Get the seat ID. Yeah, so we'll just say const seat ID is 1 for now, just as sort of a placeholder. I just want to write this stuff out just so we can get kind of a broad overview of what we're trying to do, and then we'll sort of work from both ends and get it to work. Okay, so for each part, we want to convert to binary. So we'll do the column first, I guess, because that's the part we've already done. So const call binary is what I'll call it. And there are a few ways we could do this. So the first way I'll look at is basically we'll take our column part. Now keep in mind this thing is a string. I want to do a map on this thing. I want to map it so that basically every R gets converted to a 1 and every L gets converted to a 0. So I want to do that kind of map, but the problem is there's no dot map when it comes to strings. We need for this thing to be an array in order to do a dot map. So we're going to make it an array. So here comes the spread operator. We've seen this before. Basically, the idea is that if we didn't have the spread operator, then it would basically just be an array containing one element, and that one element is a string. Okay, that's not what we want. What we want is an array containing all of the characters of this string. So that's what the spread operator does. It basically dissolves away the stringness of this, I guess, and it makes it just a list of characters. In fact, it makes it, the spread operator specifically just makes it like a collection of characters, right? It's not actually an array of characters until we put these square brackets around it, okay? Because we might be doing something else with those characters, like for example, using them as the inputs to a function. Okay, so we've got this, and now since it is an array, we can do a dot map on this thing. So we'll say dot map, and then each of these things is going to be a character. We'll just say, well, we could say something like this, you know, character equals R question mark for ternary operator, right? If it's R, then make it a 1. Otherwise, make it a 0. And notice I'm using the string 1 and the string 0. That's probably not going to matter, but, you know, just to be safe. Okay, and then we could do like a dot join on this, and I'm just going to give the dot join an empty string. That's basically like, dot join is kind of like the opposite of what we're doing here, or the opposite of doing like a dot split, right? Dot split, we would say, I want you to split on this character. Dot join, we're saying, well, we've already got a bunch of parts. We want you to put them together and put this thing in between each parts. So this is like the glue that we use to hold together all the parts. Okay, so we've got a column binary over here. And I think I just maybe want to just return this, to be honest. So yeah, let's just return column binary for now. And we'll say for passes, we'll do passes.map, and it's going to be this, process pass. Okay, cool. So by the way, you might be looking at this and thinking, wait, for .map, don't you need to do like, you know, value, like the input and output, and then like process pass of value? Like, don't you need to do this? And yeah, a lot of the time we do this just because it's a function, right? And we need this to be a function. So it needs to have an input that's going to represent like the current value of the passes array, and then an output, which is like what you want to do with that. So like we want to take in value and return process pass of value. But like process pass already takes an input, and it's the pass itself. So like we already have that set up. The fact that process pass is already a function that's taking in a single variable means it's set to be put into a map. Okay, so let's save that. and we'll run it. And there we go. Okay, so we are getting these binaries looking pretty good. I'm a little uncomfortable with a few parts of this, to be honest. So the first part is this: character equals R. I would maybe like to see it be a little more explicit and say character equals L in this part, right? And say like 0. Otherwise, maybe just nothing. Because this way, basically, if it's something other than an R or an L, it'll ignore it. Right? So it's a bit like the trim that we did over here. I'd probably like to see this level of security just in case we get something that has like a mistake in it. You know, maybe it's got like a 1 at the end, or like just, yeah, an extra space or something like that. So basically the idea is we could do something like this. We could also do something not like this. So we could do something different. Basically what I'm thinking is, we could just have like a legend object, right? We could just say if it's an R, that should be 1. And if it's an L, that should be 0, right? So this is just like an object that's kind of like our legend. And then we'll just say whatever that is at character, okay? So this thing at R is 1. This thing, this thing at 0, this thing at L is 0. Okay, so using this little legend object over here, we can quickly, or yeah, maybe more quickly convert this into our binary. So let's first make sure that this is working. Yeah, it's working exactly the same as before. The problem is it's kind of showing the same weakness as the previous thing that we were looking at, right? Because what if it's not R or L? Well, this actually makes it a little simpler. We can just say or empty string. Okay, so we're using the Boolean operator or. So this is like a logical or. And the idea behind this is, remember in the last video we talked about how like if you have something like A and B, well, this is only going to be true if both of them are true. So if the first one's false, it already knows that the whole thing is false and it's not going to bother looking at the second part. Similarly, if we had or, then basically it knows that if this part is true, it doesn't need to bother looking at this thing. So it's only if this part is false that it'll look at this. Because if it's true, then the whole thing's true. You know, one of them is true, that's enough. So basically, if this is false, and only if this is false, will it even consider what this is. So basically, we're doing a kind of a slippery thing. Because basically, what I'm saying is this thing is like a 0 or a 1. Ooh, actually, does this work? I think this might not work because I'm now realizing this is a 0. That'll probably get typecast to false, in which case this or would get activated. I didn't think about that. Okay, so basically let's prove that that doesn't work. Yeah, it doesn't work. So we can't use this here. It was a good try, but oh well. So what we could do for this is we could just say, is the character in this object? And actually I'm realizing I need to give a name to this object now, so we're going to call it legend. Just like the legend on a map, right? Something that you'd look up to see what the symbols mean. So legend is assigned the value of this object, and yeah, we're just going to say legend at character. But the way we can ask this is the character in the legend? In which case, yeah, we'll do legend at character. Otherwise, we'll just say the empty string. Don't worry about it. So let's save that and we'll run the code. And there we go. We got our zeros in here. I guess we could also just sort of mess with one of these, like put a little, no, not a 0, a 7, let's say at the end here. So now like this RRR7 will end up being column part because remember, it's slicing from index 7 onwards. So it will include that thing. And then it should disregard it because it'll be like, well, is the character in the legend? No, I don't see it as one of the keys in this legend. So no, we're going to disregard it. We're going to give it just empty string. So let's try that. And yeah, so it disregarded it. Whereas if we didn't include this part, if we just said legend at character, we would probably get some sort of undefined thing at the end of one of these. So, oh, well, maybe not. That's got me curious. So is the column part actually capturing that 7 that we had? Yeah, it looks like it is. Okay, well, good to know. So I guess what's happening here is the array is having some sort of an undefined, and it's just disregarding that as part of the join. I thought it would actually say like 111 undefined or like 111 null or something like that. That's kind of what I was expecting. So a little surprised by that, but oh well. Maybe we don't need that level of security then, but I'll just keep it in there just for fun. Okay, cool. So we've got all this stuff. That's looking pretty nice. Although I have to say, I have one more issue with this. And I'm sorry we keep redefining what we're doing here, but it's worth talking about. The problem with this for me is the fact that like we have something that's a string, right? This starts out as a string. And what we're producing with it ultimately is still a string. And so it kind of seems a little like, well, do we need to be making this an array if we know we want it to end up being a string in the end? And yeah, maybe we don't. So basically, we're going to try a new way to do this. I'm just going to delete what we have here. And we're going to say this is going to be call part dot replace. So we've looked at dot replace before. We remember that if we wanted to replace r with 1, for example, it's actually going to have a bit of a problem with this because it's only going to replace the first r. Okay, so that's not ideal. If we wanted it to be all of the r's, we need to say all of the r's, put a g at the end. Okay, and then when we run this, it should replace all of the r's with 1s. That's good, but we're still not replacing the l's with 0s. So we would then have to do like a, dot replace, and then say l, gets replaced with 0, and let's not forget the global flag on that. And this will work, but I don't really like the idea of like chaining together multiple replace functions just so that we capture multiple characters. So we could do something like this where we kind of wrap it into one. We could say if it's one of these characters, so replace, we could say like R or L. Right? And then we could maybe put this in a capture group and tell it what we want to do with that capture group. But that again is getting a little complicated. So I think what I'm actually going to do, and this might be the first time we use dot. Dot is a really powerful character in regular expressions. It basically means match any character. So this is going to match any character, and it's going to replace it with, well, it's going to take the character, and it's going to be just what we said before. So is the character in the legend? And if it is in the legend, we'll just say, oh, well, just give us whatever it is then, legend a character. Otherwise, just give us an empty string, okay? So if we save this, we should find that it's working, and it is, so that's good to see. And I think I kind of prefer this just because like we started with a string. Let's go ahead and end with a string. That probably is a better way to do it. So let's do the same thing with the row now. Row binary is going to be row part dot replace. Now that we've got this figured out. And you might be wondering like, well, hey, are there other ways that we could do this? Could we chain together these replaces in another way? And yeah, absolutely. Absolutely. There are many, many ways to do this. So these are just, a few of my favorites, I guess. Okay, so basically for this part, we're going to need a new legend for this, right? We can have like our row legend and we can have our column legend because they're going to be different. So I'll call this column legend and I'll call this row legend. And the rows are all about backs and fronts, right? So I think the back is going to have 1 and front is going to have 0 because the numbers go up as we go from the front to the back of the plane, just like they go up as we go from left to right. Okay, so now we have 2 legends, so we'll get our column legend in here. There we go. And then we'll do basically this same thing. In fact, it's going to be so similar. I'll just copy it over. And then we're going to replace column legend with row legend. Yeah, nice. Okay, and now we have row binary. Let's go ahead and just return row binary for now. Uh-oh. Okay. Yeah, oh, that's just a syntax error. My mistake. I'm sure many of you noticed that as I was doing it, and it was a painful moment, so I apologize for that. Okay, yeah, so we're getting some stuff here, which I think is probably correct, but it's hard to tell since we're not actually looking at these in terms of their decimal values. So let's get our decimal values. So we'll say row decimal is going to be, well, this is the fun part. So you remember we've done parse int before? If we just do row decimal, that's like parse int of row binary, then a funny thing happens. So we'll just return row decimal for now, just so we can show it in the console. So it's just like literally converting these into decimal numbers. Like, oh yeah, sure, you want 1,110,000? Sure, yeah, I can give you that. Oh, I don't know why you included leading zeros in this one. It's just 1,110. So basically, we can use parse int here, but we need to specify as a second optional value here. We need to tell it what base we want. So we're coming from binary, which means base 2. So now it should be a little more intelligent about how it's doing this. So we're getting 70, we're getting 14, and we're getting 102. Now, if we do compare that to the problem description, 70, 14, 102, it's looking good. I'm pretty happy with this so far. I'm thinking we've got the right values. So we've got row decimal. Let's go ahead and get column decimal. We'll say parse int, call binary, and 2, of course, is going to be very important. And then we'll get our seat ID. Yeah, we might as well get our seat ID. So going back to the problem description over here, it says that we want to multiply the row by 8 and then add the column. Okay, so basically, let's go ahead and do that. We'll say seat ID is going to be row decimal times 8 plus column decimal. Okay, and then seat ID is the thing we want to be returning, so we'll save that. And when we run it, we get these three numbers, 567, 119, and 820. You know what? Those seem a little bit familiar. I think I've seen those numbers before somewhere. Trying to think of where. Maybe it'll come to me. But anyway, yeah, so I think we've got the right idea here, or at least I think we're getting the correct values from this. So I actually want to take a bit of a step back from this, and I want to go back to this thing that we noticed before about the conversion to binary, the fact that these do end up being binary numbers. I want to talk about why this is. Like, we see that it does seem to be the case, right, that these do line up, but let's think about specifically why that is, and then we're going to make a bit of a connection to this next part that we're working on. So basically, for this, when we see R over here, this is telling us it's on the right half, right? So in other words, it's saying if you were starting from 0, move over a full half here, right? So when we say a full half, oh, whoops, that's not what I meant to do. Okay, sorry about that. Yeah, when we say a full half, what we're talking about is basically 4 values, right? So if we have an R here, that's going to count for 4. We're going to add 4 to the result. Okay. If it was this one, right? If this one is an L, so we're adding nothing to it. But if it was an R, equivalently if it was a 1, then how many would we be adding? Well, if we were starting here, we'd be adding 2. If we were starting here, we'd be, whoops, let's draw a better arrow. If we were starting here, we would also be adding 2. So this one represents 2. Okay, that's like the place value for this. If we look at the last one, no matter which of these halves we were originally on, we're going to be moving over just 1 to the other part of that half. So this one has a value of 1. Okay, so this is what we're noticing. Basically, the idea is that these have the place values equal to binary because that's how many spaces we actually have to move over. Okay, so why am I mentioning this now? Well, I think there's a bit of a connection to what we were talking about over here. This might seem like a really random formula, this idea of like multiply the row by 8 and then add the column. So I want to work through one of these actual examples here. I want to get the actual values that we get. So let's just do a little console log of our row binary and our column binary. Yeah, okay, cool. So let's get that. Yeah, okay, so I think the one I want to work with is this third one over here. So let's take a look at that. I'm probably just going to move over from this. So we'll just pan over to the next part of this. We can go back later. So, you know, we haven't lost our progress. It's not to worry. Okay, so if we look at what the row value is, it's, yeah, I think we said we were going to use this one. So 1100110. So yeah, we'll just say row 11001110. Okay, cool. And then the column part was just 100. So we'll list that. Okay, yeah. So basically, like we were talking about just a second ago, we have sort of like the 4 column, the 2 column, and the 1 column. We could continue with these and say these represent 8s, these represent 16s, these represent 32s, and these represent 64s. So if you think about it, like the largest number you could get by adding all these up would be 127. So that makes sense because that is the largest value we could get for our row decimal. But keep in mind, we need to multiply that by 8. So let's think about that for a sec, okay? So let's, yeah, what's the best way to write this? I'll just do it here. So we'll say 128 down here, and then we'll say 64, and then 32, all the powers of 2 that we know and love so well. Okay, so there we go. Basically, here's what I'm trying to say. Let's think about the number we had a second ago. So 110, maybe it'd be, no, that's fine. I was gonna say maybe it'd be easier to work with the smaller of these 2 numbers, but this is fine. So let's think about this. This number is equivalent to 64 plus 32, you know, like this is another way of writing this number. 64 plus 32 plus 4 plus 2. Done, right? We could write it out that way. So the reason I'm saying this is because if we want to double this number, it's the same as doubling each of these. So we'd say, okay, well, double this is 128, double this is 64, double this is 8, and double this is 4. So what does that number end up looking like? Well, it's a 128, it's a 64, it's not a 32, it's not a 16, there is an 8, there is a 4, there's no 2, and there are no 1s. Hey, are you noticing a pattern here? Check it out. Basically, every one of these things just shifted over by 1. Just shifted. Okay, cool. Not bad. So then, anyone want to guess what would happen if we tried to multiply this number by 4 instead of multiplying it by 2? Yeah, great guess. It's going to shift over 2 spaces, right? Because multiplying by 4 is just the same as multiplying by 2 twice. Okay, so basically multiplying a number by 2 shifts it over. And we actually have sort of like syntax for this. So here where we see row decimal times 8, I mean, we could treat this like a binary number. And instead of times 8, we could say shift this over 3 times, okay? So this is called a bitwise shift. And basically it works just like what we see on the left side of our screen here, okay? This would be a shift by 1. A shift by 3 would basically, whoops, it would take this number. So let's write this out down here. So 11001110 shifted by 3 is basically going to mean that we're going to get 3 new zeros on this end and then the rest of the number. So it's a much bigger number. It basically just has some 3 extra zeros over here. Okay, cool. So, you know, nice to know, I guess, but what's the point? Great question. So think about this. What effect do we have when we add on column decimal? Well, keep in mind, column decimal is only 100. It's necessarily only 3 digits. So basically, if we have, and I'm just going to draw sort of a horizontal rule over here. So basically, if we have this number, and then we want to add to it this number, well, keep in mind, like this stuff up here, this is all zeros. We know that. This part is all zeros because we just did this shift by 3, and that fills in with zeros. These parts here are the only parts of this number, which means that actually all of this is zeros. So when we do this addition, it's going to be no different from a bitwise AND, because we know that these ones are all mutually exclusive. There isn't a single spot here where they're all ones. Okay, so if I want to actually combine these things, if I want to do the addition of these two, basically it's going to be 1, 1, 0, 0, 1, 1, 0. In other words, the entire column binary, row binary, and then 1, 0, 0, which is the column binary. So basically, all I'm trying to say is, like, think about what we did here, okay? We started this problem by splitting up the row part and the column part. Then we converted each of those to binary. Then we manipulated those binary numbers to put them back together in the exact configuration that they came in. So this is how it started. Like, this is what we started with over here. So basically, all I'm trying to say is that there's probably a way we could do this without dividing it into row and column parts, okay? So let's go back to our full IDE and we'll talk about how we can do that. So you remember how I said the description was a little bit sneaky? So number one, yeah, it's sneaky because it doesn't just tell us that we need to use binary here. But number two, holy, the whole thing about the multiplying by 8 and adding 1, is that ever a sneaky way to basically tell us you don't need to split these up? Very clever. So, I mean, again, that's just a testament to how well written these challenges are. You can always tell when thought has gone into it. You know, I've seen a lot of coding challenges, and the quality here is just delicious. Okay, so the first thing I want to do in terms of going towards amalgamating these two things is I'm thinking, well, as a first step, as a sort of a first peace offering between these two different parts, let's make an amalgamated legend. So we're just going to make a single legend variable, and it's going to contain both of these. Okay, so actually, yeah, another way we could say this, check this out. We could basically say legend is going to be row legend and column legend. So spread operator is an interesting thing because it actually works on objects as well. I think we saw this in the previous task, but it was we went pretty fast over it. So basically, all I'm trying to say is, like, all of these key value pairs are going to be put into this new object, and all of these key value pairs are going to be put into this new object as well. So if we were to then say, like, console.log, whatever legend is, it should now just be one thing where they're all together and everyone's very happy. Okay, so I'm just going to copy that and paste that in, because that's really what we're looking for. And this, like, row legend and column legend stuff, this is an artifact from a time when we were divided. We're no longer divided, we're united. We don't need to use a separate legend for each of these because it's the same thing. I mean, like, it's basically just replacing these things with the values they're supposed to be, right? Like, yeah, there we go. So now it still works. I guess we don't need to be console logging the stuff that we currently are, so we can get rid of that. And now this whole idea of splitting it up and then doing this stuff and then bringing it back together, let's not do that. So basically, we won't split it up. Don't divide it. For each part, no. For the one part, convert it to binary. How are we going to do that? We're just going to call it a single thing called binary. Hopefully that's not a built-in keyword. We'll see what happens. But yeah, binary is just going to be this thing. We're going to take not row part, we're going to take the full pass, and we're going to replace every single character with whatever the character in the legend is, if there is a character in the legend. Otherwise, we're just going to give it an empty character. Okay, great. So row decimal, column decimal, I don't even know what row binary and column binary are. But what we can say is, well, we could just make this a decimal. You know what? It's just the seed ID. It's just the seed ID, right? Because the seed ID is the thing that we would get by, combining all these things like we saw over here. So basically, the seed ID is now just going to be this thing, parse inted. So it's just the binary converted. And then we're just going to return seed ID. And let's see, what should we expect? So this is like 567, 119, 820. Those are the correct values. And so if we run this, oh, you got to love that. Okay, so this is great. This is great. I feel so much happier knowing that there's unity between these two parts now. It was really, it was bothersome when it felt like they were fighting. That wasn't nice. So this is much nicer. Now, if you really wanted to make this like, for whatever reason, if you didn't want to assign all these variables and stuff like that, we could actually just take this, like this is what binary is equal to, right? This whole thing. So we could actually just take that and put it in for where binary is. And then seat ID is the thing we're returning. So we could actually just say return just this thing, right? So we're finishing up with our parse int. I think that's it, actually. So if we look at that, oh, no, we've got a mistake. We've got a return seat ID. Yeah, jeez, didn't even see that. Didn't notice that was even part of it. Wow, there's so much we were able to get rid of. And we still get the right values. So beautiful. Okay, good stuff. So I'm just going to move this down because I'm remembering this response text thing is, we're not going to use that. So yeah, basically just the stuff below is what we're going to end up eventually pasting in. Well, actually, I say eventually, but do we have what we need now? Well, let's see. Let's consult the problem. Right, so we want to know what is the highest seat ID on any of the boarding passes. So in this case, it should be 820, right? Let's try to find a way to do that. So we basically have all of our passes. Actually, here, I'll just say const seat IDs. And it's just going to be this passes.map thing. So that's the thing that we were console logging. And let's, I guess, continue to console log that. So if we look at this, yeah, nice. It's looking the same. Now, what we actually want is the maximum ID. So I'll just call this max ID. And it's going to be, well, there are a few ways we could do this. We could do like a dot reduce on seed IDs and see which one ends up being the maximum. So actually, yeah, if you're interested in seeing that, basically it would be like seed IDs dot reduce, and then we would say like, I'll just call this one maximum and I'll call this one ID because it's like the current value. If you remember in a reduce, it sort of like rolls these up. So the initial value for this thing, I'll just say is 0. We could make it like something much smaller, like negative a billion, if you wanted to. That's a shorthand for 10 to the power of 9. But anyway, okay, so basically for this, we want to say which one's bigger. Sorry, I'll put it this way. Is the ID that we're currently looking at greater than max? If so, then give us ID. Otherwise, give us max. Okay, so it's just going to go through each one. It's going to start with a max value of negative a billion, and then it's just going to look at each ID. So it'll look at 567 and say, is that greater than a billion? Oh, it is. Okay, so return that, return 567, which means it'll assign that to the value of max. So then when it moves on to the next one, it'll say, well, max is 567. Is this thing, ID is the 119 now, is that bigger than 567? No. So just go with max, which was 567. So we still have 567 as max when we go into this next one, and we say, oh, okay, so ID is now 820. Is 820 greater than 567? Actually, yeah, it is. So return 820. And now max is going to be 820, but we're at the end of the array. So we basically just return that 820, the current value of our accumulator here. And that's what we're going to get. So if we do our max ID that way, we should get, yeah, oh, whoops, I meant to return max ID. We should get 820. Nice. Okay, good. So this is a way we can do it. And it's always nice to be really comfortable with, oh, sorry, I didn't even realize I wasn't showing the full thing on screen. Sorry about that. So this is a way to do it. And it's always nice to be comfortable with reduce functions because in functional programming, like we use these a lot, right? They're really, really useful. But we don't actually need this here because we could just do math.max. It's a built-in in JavaScript, yeah, math.max. And we could just say, yeah, math.max of like, for example, the 2, 3, and 7, what's gonna be math.max of that? I just want to sort of show how this function works in case anyone's unfamiliar. It's 7, okay? If we were to make this like 21, for example, then now that's gonna be the maximum value. So we could put in seat IDs and it's gonna be like, I don't really know what you're talking about because we're basically asking it like, hey, what's the maximum of this single array? Like we're giving it, number one, we're giving it something that we can't really compare and find a maximum of because it's an array. And number two, we're only giving it a single element. How do you find the maximum among a single element? So like, this is really not what we're looking for. But the moment we make it this, remember, we use the spread operator to dissolve away the square brackets on this. And now we're getting something that makes a little more sense. So we're going to put in seat IDs here. Got to remember to use the spread operator. And now we get our 820. Okay, great. So max ID is going to be the answer that we're looking for. So let's go ahead and find the official answer. So I'll just grab my fetch code to get these first two, the response and response text. We'll bring up our browser console. We'll get that request in, and then basically everything after response text is what we want to paste in. And I gotta say, geez, this is not that much code. It really shrunk down in the end. Okay, 906 seems to be the value that we're getting. So that's what I'm gonna go ahead and enter, 906, submit. Hey, there we go. Looks like we got it, so we can go ahead and continue on to part two. Now, part two, I think this is a really interesting one. So it's the same, like the conversion part that we did. So like all this like seat ID stuff is going to be just as relevant as it was before. And actually, I'm realizing this comment is maybe not great. Let's just say convert boarding pass to seat ID. That's better. Okay, so now we want to do something a little bit different with these seat IDs. So now it's saying, oh, whoops, there was a mistake. Actually, your boarding pass is not on the list. However, the boarding pass that's just the one that has a seat ID that's one greater than yours and the one that has a seat ID that's one less than yours, those two are in the list. And so we can assume quite a bit from that. We can assume, number one, there's probably only going to be one possibility for that, right? So like basically, if we know that our number is not on the list, but there is one above and there is one below, then those two, the one above and the one below, are going to be spaced out by exactly two, okay? So we should be able to find that there's only one pair of seat IDs in the list that are spaced out by exactly two. So that's our job, okay? I'll just write that down. Find the seat IDs that are spaced out by exactly two. That's our challenge for this part. And we don't really care about the max ID anymore. I'll just keep it there. Okay, so we're done the seat ID conversion part. It was fun, we loved it, and now it's over. So we're gonna do this thing now. We're gonna use two different strategies for this. So the first thing we wanna do is basically, I figure if we're looking for the differences between these things, it might be a good idea to actually just sort the array. Now, what we found in previous videos is if we do seat IDs.sort, number one, we're going to have to provide some sort of callback that tells JavaScript how we want it to be sorted. But number two, I actually got a really interesting comment. So the viewer Red Omar suggests that by doing this mutating method, that's not really as immutable as it could be. So we're not really following the functional paradigm as well as we could. And that's a really great point. So originally I was thinking about this and I was kind of thinking, well, seat IDs is an array. It's still a constant. There's still a constant binding between the array and, the seat IDs variable and the array that it's bound to. So even if we're rearranging some of the values inside the array, it's still a constant binding. So I figured that's immutable. But I think the idea of mutating an array, it could have unexpected results. So I like the idea of actually creating a new array of this. So let's actually say const sorted IDs. And it's going to be seat IDs.sort. Okay, so now we have a new array and it's just the result of sorting these seat IDs. But there's still a problem, and that problem is the fact that when we do seat IDs.sort, it doesn't matter if you're assigning it to a new variable, it's still changing what's actually inside of seat IDs. So since we don't want to change seat IDs, we're going to create a new copy of it. So fastest way to do that, I think, is basically just use the spread operator. We're just saying we want every element from inside this array, and then we're going to make a new array out of that, and then we're just going to sort that. Okay, so it's up to you if you want to do it this way, or if you want to say sorted IDs is just this new copy and then sort that. But no, it's better to do it this way because, like we talked about, that's a mutating method. It would kind of defeat the purpose to do it in 2 steps. Okay, cool. So now we've got our sorted IDs, and let's see. We want to find. Okay, so find. Oh, actually, I just wrote that comment right here, actually. That's what I was about to just write. So basically, how are we going to find that? Well, one way we could do it, the sort of non-functional way we could do this. I don't mean non-functional in the sense that it's not going to work, but not adhering to the functional programming paradigm. Basically, the way we could do it more traditionally using loops and stuff like that is to loop through and just say, okay, compare the current element to the next element. And if there's a difference of exactly 2 between them, then you found it, right? Stop the loop. I don't really want to do it that way, so I'm going to do this using filter. So we'll say const candidates, I guess, because really there should only be one that we find here, but just in case we have more than one, we'll say candidates. And I'm going to say sorted IDs dot filter, and then we're actually going to use a callback with 2 arguments here. So it's going to be ID and the kind of unfortunately named I. I'm going to go ahead and call this index just to be clear about what I mean, because ID and I feel a little too similar. Okay, so filter, as we talked about before, filter is going to take a callback function that returns a Boolean, or at least something that's going to be typecast into a Boolean. And if that Boolean ends up being true, it's going to keep the corresponding element in the array. If it turns out to be false, it's going to remove that corresponding element from the array. And I should also mention, maybe it's a misnomer to say keep and remove, because basically this is a new array that's being created. The filter is not a mutating method, so we don't need to worry about that. So what we want to do here is basically take the current ID and compare it to the one above it, right? So what's the one above it? Well, the one above it is going to be sorted IDs at index plus 1, right? And then we'll just say that minus ID. That's the difference between them. And is that difference equal to 2? And that's it, right? We want to filter according to this. This is a Boolean. This whole thing is a Boolean. We're saying the difference between the next number and the current one is equal to 2. Now you might wonder, what about when we get to the end of the list and there is no index 1 or index plus 1? Yeah, great point. So what's going to happen then? Well, sorted IDs is going to be undefined, and we'll do undefined minus ID. It's probably not going to be equal to exactly 2. That's my guess. Either that or there's going to be some kind of an error, in which case that would be lots of fun too. So let's find out what happens when we run this. We don't get an error, and we don't get an answer. Oh no. Why not? Okay, let's see what sorted IDs actually looks like. It's possible I sorted it in the wrong order. Yeah. Is that sorted in the wrong order? A minus B? It looks like it's ascending. So, sorry. It's not because I sorted it in the wrong order, actually. It's because we don't have the full complete set here. So let's actually... geez. Yeah, okay, we can do this. So like this one over here, the seat ID here just needs to increase by 2. So we can use our knowledge of binary to figure this out. So it's going to be the same up to close to the end here. So this is like 1, 0, 0. We want to add 2 to that, so it'd be 1, 1, 0. So RL. Yeah, let's try that. So now this one was 820, I think, right? So this one should be 822. And then we should get as our final candidate just like an 820. Yeah, cool. So good, but that's not what we want. We want candidates. Great. Okay, so basically we should end up having only one element here. And actually, check this out. There we go. The single element that we're looking for. Okay. Now I don't believe it's possible to actually then like do arithmetic on this. I've never tried it, but I don't think it'll work. Yeah. Okay. So it did something a little weird here, right? Like, candidates plus 1. It's because it viewed it that way. Well, that's not what I wanted. I wanted you to spread operator the candidates and then add 1 to it. At this point, we're just doing this to satisfy my own curiosity. So I'm sorry you had to be here along for the ride, but yeah, okay. So it doesn't like that. It's like, what are you talking about? Come on, start. start making sense. Okay, so there we go. Candidates at 0 plus 1. That's really more what we wanted, right? You might be wondering why the plus 1? Well, remember, we're looking for basically our missing seat ID, the one that's not in the list, but we know that the seat ID directly below and directly above this are in the list. And so that's why the answer we're going to need to add 1 to. So yeah, it looks like this is going to work. This is going to be a way to find it. And it's a pretty good way. I mean, when we do our sorted ID thing, basically this is big O of n times log n in terms of time complexity. We mentioned that before, I think, in the first video. And so that's pretty good. Like that's definitely decent time complexity. The question is, can we do better than that? And the answer is, yeah. We can actually. So basically, this is actually kind of interesting. I'm kind of torn as to whether we should like submit this first and get our answer, or whether we should sort of find our more optimized or maybe more optimized strategy and then submit one of them after. I guess we've sort of proved that this is working using our sample data, so I'm satisfied with that. Let's try another way to do this. So basically now, instead of sorting, I'm going to do another strategy. This, again, might remind you of the first video. So I'm going to make a set, okay? And it's going to be ID set. It's going to be a new set that comes from the seat IDs. And so notice, in order to do this, we did not have to sort. So we're going to avoid this n log n time complexity. The other thing I'll say about this is basically, in order for us to search this thing and find our candidates, which I'll just call this candidates 2 for now, we'll do a dot filter on not sorted IDs, but on seat IDs. And basically, in this case, we don't need to know the index, just the ID itself. And all we need to ask is the simple question. So ID set dot has ID plus 2. Simple as that, right? I think that's all we need to check. So let's go ahead and run that. And what do we have here? Do we have a case where I didn't use the right parentheses? Oh, I have a semicolon. Whoops. Yeah, that semicolon habit is just too strong. Okay, yeah, so we're still getting, oh, wait, no, that's not the right thing. Candidates 2. I know, let's just return the whole candidates 2 array this time. Yeah, so it still just has 820. Great. So that's nice, but there's a bit of a problem with it. And the problem lies here. What if we actually had another one of these that was this? The problem is now 821 actually is in the list, and this one would still say that 820 is the answer. So we actually need to be just a bit more specific. We need to say that the ID set has the ID plus 2, and that it actually doesn't have the ID plus 1, because the ID plus 1 is like the one that's supposed to be missing, right? Okay, so candidates 2, it should work now. Yeah, no candidates, because we put in, well, both of them should return that result, that there are no candidates, because we put in one that made it impossible. Okay, cool. So I'm happy with this. I mean, what I like about this is there's going to be like a big O of 1 time complexity to look this up, right, for each one of these. And we avoid, so like this is the same complexity as this, but we avoid this whole sort. So we get this in big O of n instead of big O of n log n. So I think that's nice. I think it's good savings. Let's go ahead and submit our answer. This has been a long enough video. So let's save this stuff. And basically the idea is that we're going to take these two things and get our input that way. And then we'll get all of this stuff that happens beneath response text. We're going to do that to get all this seat ID stuff. And you know what? Actually, just for now, I'm just going to do this. We'll just get rid of the sorted stuff. And we'll bring it back after. I just want to prepare this to sort of paste in. Okay. And it looks like 519 is our answer. Okay, so actually one last thing I want to do, I just want to verify. Yeah, so for candidates, it looks like there's only one thing in there, which is perfect. You know, so 519 probably is the answer here, unless we made a terrible mistake, which is always possible. And it looks like against all odds, we did not make a mistake this time. Whew. Okay, who would have ever expected that? So, nice job. Just going back to the full code screen over here, I'll do a couple undos just so that we don't lose all of our code. And basically what I'm going to try to do is get this stuff uploaded to GitHub. I'll probably clean up the code a little bit because I'm sure it's pretty gross in a lot of ways. Maybe we'll get some more comments in there and stuff. But anyway, I'll see you again soon for the next video. In the meantime, remember to believe in yourself. Anything's possible. Bye!